Greetings to all. My name is Meet Gohil and I'm a student of Masters in Construction Engineering and Management at SEPT University, Ahmedabad. As a part of my directed research project, I have chosen the topic of examine, assess and improve the efficiency of labor productivity using lean approach to construction under the guidance of Dr. Nimesh Bhatt, who is a assistant professor at Pandit Dindayal Energy University and has an extensive work experience with project management and lean approach on construction sites. Here is the roadmap to the presentation. At first, we would introduce the topic and the need of the research, followed by the literature review, which helped me to develop and detailed insight on the topic. Then we'll set a research methodology defining the step-by-step process of research followed. Then we'll collect the data from the field as in case studies with both qualitative and quantitative approach. Based on the data collection, data analysis was carried with conventional and lean approach to evaluate the current labor productivity. Leading to the recommendations, a detailed solution to the problem was investigated implementing lean approach of visual management and a labor productivity tracking device. Then we'll discuss the future scope of work and conclusion to the study. As we all know, labor productivity is crucial in construction as it directly impacts projects' profitability, schedule adherence, and overall competitiveness of construction firms. Efficient labor utilization ensures cost effectiveness and timely completion of the projects. In order to achieve this, the DRP topic was proposed as examine, assess, and improve the efficiency of labor productivity using a lean approach to construction. The main expected outcome of this was to significantly enhance labor productivity within the construction industry by applying lean principles such as foreman delay survey, last planner system, work sampling. Not only this, also to gain a deep understanding of productivity dynamics, identifying critical influencing factors, proposing strategies, measuring improvements, and ultimately improving construction project efficiency. The main aim of this study is to thoroughly analyze and improve labor productivity efficiency in construction by implementation of lean methodologies. Talking about the objective is to track and improve the labor productivity on a construction site. The formula commonly used to calculate labor productivity on construction site is the output representing the amount of work completed or unit produced by the input representing the labor input typically measured in labor hours or number of workers. The main objective of this directed research project are as follows: evaluating current labor productivity, conducting a thorough examination of the existing state of labor productivity in construction by analyzing key metrics such as output per unit or cost per unit of the work, cycle time and quality. Second is identification of influential factors. Identifying and assessing the various factors affecting labor productivity, including workforce skills, management practices, technological utilization, and overall work processes. Application of lean principle that states implementation of lean principles to scrutinize and streamline construction operations, aiming to eliminate insufficiencies, reduce waste, and enhance the overall value generated by the workflow. Quantification of improvement opportunities that quantifies potential areas of improvement in labor productivity through the lean approach with a focus on minimizing non-value adding activities and optimizing resource utilization. Next is developing intervention strategies. Proposing targeted intervention strategies based on findings, utilizing lean principles to address identified challenges and sustainably enhance labor productivity. Validating the implementation of the proposed intervention and validation of their effectiveness through real-time monitoring and measurement, ensuring tangible improvements in labor productivity. And last, providing recommendation for implementation, offers practical recommendations for the implementation of lean strategies in construction project management, forecasting a culture of continuous improvement and efficiency in labor productivity. We can visualize the timeline of the directed research project as in total of 16 weeks, outlining specific tasks such as project kickoff, literature review, etc., arriving to each month as outlined. There were two milestones derived, first one at the end of third week concluding in literature review, and the second milestone was at the end of the 10th week at the completion of the data collection. The major factors influenced by the labor productivity at a wider scale are as follows. The first, GDP growth. Higher labor productivity contributes to economic growth by increasing the output of goods and services per worker. This in turn can lead to higher gross domestic product growth rates for a country. Wages and standard of living. Increased labor productivity can support higher wages and improved living standard for workers. When workers are more productive, they can earn higher income, leading to improved quality of life. Employment growth. Labor productivity can influence employment rates, while higher productivity can lead to job creation in certain sectors. Economic stability and government policies. Labor productivity is a key indicator used by policymakers to assess economic performance and formulate strategies for sustainable growth. Policies aimed at improving productivity can have widespread effect on economic stability and prosperity. Investment and innovation. Higher labor productivity encourage investment in capital and innovation. Developers, contractors, businessmen are more likely to invest in technology, training, and research to enhance productivity level, driving overall economic development. Resource allocation. Efficient labor productivity allows for better allocation of resources within an economy. It enables industry to produce more with less, optimizing resource utilization and reducing waste. Competitiveness. Countries with higher labor productivity are often more competitive in global markets. Efficient production process and high output per worker can lead to low costs and improved competitiveness at an international trade. Literature review. A detailed literature review was carried out for the following thesis, out of which 5 of the research papers are highlighted in the slide. The first one is of Anu Thomas, Factors Influencing Construction Labor Productivity in 2013. It highlights the critical aspects of construction labor productivity, factors influencing it, the role of lean principles, existing challenges, and the proposed aim of future research to bridge the gap. The main challenges found out in this paper were recruitment and retention challenges, payment delays and resource shortage, motivation, supervision and site conditions, rework, planning, communication issues and technology utilization were the main issues. Moving ahead to the next research paper written by Remo Aziz of application of lean thinking in construction and performance improvement in 2013. It states rework due to poor planning and underutilization of technology are the main issues that address poor labor productivity on construction site. Moving ahead with the next research paper written by Mr. Dixit and company of relationship between skill development and productivity in construction. It signifies the relationship between skill development and construction productivity, consistency in productivity performance within the industry, increase in qualification attainment levels, and training participation rate over time. It also highlights the construction productivity trends. Line graph showing the trends in gross value added per worker over the study. It also enhances and shows bar chart illustrating the increase in qualification attainment levels. As a result, the skill development and training plays a vital role in improvement of labor productivity on construction site. Moving ahead to the next research paper written by Mr. Ratilal Patel and company, namely productivity improvement by implementing lean manufacturing tool in 2018. Various tools and techniques such as lean manufacturing, Six Sigma, Lean Six Sigma, and ISO implementation have been illustrated in reshaping manufacturing operation and improving competitiveness in volatile economies. It also shows 7 types of waste, reduced, reducing lead time and optimizing value adding processes. It also shows total quality management and total productivity maintenance in the research paper. Moving ahead to the last research paper shown in the screen, written by Mohammad Hamze in the year 2022, namely Construction Labor Productivity Review of Factors Identified. It identified and categorized the factors ranked by its importance. Geography, variation in construction labor productivity factors. Regional and difference in factors importance. The main important part of this was the segregation of the factors showed in the research paper. Inference to literature review. There are two major inferences found out from this group of case study taken for literature review. The first inference is poor labor productivity on construction site, and the second inference is barriers to lean implementation in construction. Talking about the first inference, that is poor labor productivity on construction site, is due to lack of skill and experience, lack of workforce management, lack of project planning and scheduling, lack of availability of resources, and payment issues. Talking about the second barrier, that is barrier to lean implementation in construction, is due to resistance to change, cost and investment in training, complexity of the project, lack of knowledge and expertise, and tedious and rigorous organizational structure. Moving ahead to research methodology, a flowchart summarizing the entire methodology adopted for the research is as follows. Moving with start, the initial start was done with an intense literature review, which contains journal articles, research papers, web pages, books chapters, conference proceedings, and theses. Next step was to decide the research methodology, in which way the whole research will be conducted. Moving ahead to data collection, data was collected by surveys, interviews, detailed interviews, conventional case studies of labor productivity, and lean implementation to analyze the labor productivity. Then the data was validated by cleaning and pre-processing the collected data. Next, the data was analyzed and defined. A problem statement was generated which will be solved by the data available. that is low labor productivity on construction site. Recommendation of visual management as a lean approach and a labor productivity tracking device was recommended. Moving ahead to future scope and conclusion, and this ends the flowchart. See a data collection flowchart in which it is detailed described how the data was collected and in how many sections the data was distributed. Basically, the data collection was done by survey, interviews, detailed interviews, and lean approach. Moving ahead with the surveys, there were two surveys carried out. Basically, primary survey that was communication with the laborers, and the main survey which was on the construction site. Moving ahead with the interviews, there are 65 number of interviews which were responded and collected as in data from the construction site from the site personals. Moving ahead with detailed interview, there are total 108 detailed interview carried out throughout the 4 months of time period, and this detailed interview were done at the higher authority or higher management of the contractor or developer in order to get an overview of what the higher management is thinking. Moving ahead with the lean approach, in lean approach, last planner system, work sampling, foreman delay survey were conducted on different sites in order to get a proper data collection of the labor productivity. Note, the number defined in the flowchart are the count of responses considered for the research paper. The survey conducted on various construction sites in Ahmedabad aimed to gather quantitative data from diverse range of participants regarding their experience, challenges and perspective related to construction work and labor productivity. In this project, the data analysis is done in two bifurcation. First is qualitative analysis and second is quantitative analysis. Qualitative analysis contains CPO analysis. Moving ahead with the legal compliances hindering labor productivity. Next is linear responsibility chart created for labor productivity on construction site, and last is the risk management associated with labor productivity and labors on construction site. Talking about quantitative analysis, it contains of the analysis of surveys and interviews questionnaires. The next is implementation of lean principle as foreman delay survey, last planner system and work sampling on different sites to create an inference for labor productivity on construction site. And last is the conventional way of analyzing productivity in which there are two case studies taken and analyzed. Context, problem and option analysis. Under context analysis, pastel analysis was carried out for labor productivity in construction site in Ahmedabad. Highlights various external factors impacting the labor productivity. The major political factors are political stability and government policies and regulation. Under environment, environmental regulation and sustainability is the major factor. Second is natural disaster and climate related risk which are associated to labors directly. Talking about social factors, the demographic trend influencing labor supply and demand, and second is cultural factor affecting work practices and labors. Under technical factors, adoption of technology and automation in construction process, and availability and accessibility of advanced tools and equipments on site to improve labor productivity is essential. Under economic growth and stability of labors is an important factor influencing labor market conditions. Considering legal factors, compliance with safety regulations and standards is a major influential part with contractual obligation and legal frameworks. As an inference, there are two major factors, that is economic factor and legal aspect of pastel analysis, which influence productivity by shaping labor market condition and impacting investment levels in construction, affecting wages, labors, and skilled labor availability. The legal aspect is a crucial for labor productivity, ensuring compliance with safety regulations and contractual obligations, thus fostering a convict environment for efficient construction operations and improve in labor productivity. Talking about problem analysis, we have developed fishbone diagram, that is Ishikawa diagram, for low labor productivity on construction site, and we have found out material, method, manpower, machinery and environmental factors which ultimately concludes to low labor productivity. Starting with manpower, lack of skill level manpower, availability of skilled laborers, lack of training programs for laborers, and workforce motivation and morale of the laborers affect low labor productivity. Second is methods, old construction techniques and practices, inefficiency of work procedures, utilization of technology and tools is not proper, coordination between different trades is not proper. Third is machinery. Availability of the construction equipment on site is missing. There is lots of maintenance, high maintenance of the machinery available on construction site. Suitable machinery is not available for specific tasks, and adequacy of equipment for the project scope is not proper. That ultimately concludes to low labor productivity on construction site. Why? Because this creates a waiting time for the laborers. Moving ahead to environmental factors, that is weather condition affecting work progress, site layout and accessibility, safety regulation and enforcement, and comfort and ensure for laborers on site. So these are the major factors in material, method, manpower, machinery and environment, which ultimately concludes to low labor productivity on construction site. For option analysis, there are two options proposed. First is training and skill development, and second is enhancing communication channels. In order to improve the option and explore the option of training and skill development, it is divided into further 5 bifurcation, namely skills inventory analysis, which conducts an assessment to identify existing skills and competencies within the workforce and determining the gaps between required skills and availability of the skills. Next is training needs analysis. Utilize skill inventory finding to pinpoint specific areas required training, and considering an external consultancy for need to identify training priorities. Moving ahead to third is tailored training program. It is very necessary to develop a training program that directly aligns with the identification of skill gaps and job requirements, ensuring training content focuses on enhancing job specific skills and knowledge. Fourth, benefits of effective training. This is to discuss the impact of high quality training on employees' performance and productivity, and highlight the potential of new skills and behavior to be integrated into the workplace. Last is cost effectiveness, that is to address the cost implementation of training initiatives as a suggestion of offsetting training costs through increased in productivity. Now moving ahead to the second option, that is enhancing communication channel, can be achieved by four major parts or four major subcategories, that is challenge and change with subcontractor communication, identifying common issues faced due to busy subcontractor schedules and disperse the team, highlighting the importance of clear communication of project success to the subcontractors. Moving to effective communication strategies that emphasize the need to eliminate an ambiguity in task required for subcontractor, and proposing leaving detailed work packages at the site to ensure clarity to each and every subcontractor. Moving ahead to benefits of work packages, that is to explain how work packages simplify the task understanding of subcontractors, providing examples of what a work package could be, including task explanation and drawing or etc. Moving ahead to last factor, that is implementation and cost, which emphasize the simplicity and cost effectiveness of implementing work packages and highlighting potential benefits in terms of project efficiency and reduce misunderstanding. Legal compliances. The following legal compliances were studied for the labor productivity, and they are as followed: Building and Other Construction Worker Regulation of Employment and Condition of Service Act 1996, the Contract Labor Regulation and Obligation Act 1970, Minimum Wages Act 1948, and etc. The major challenges found out in ensuring legal compliances on construction site are as follows: establishing a legal register, complying all relevant laws and regulations applicable to construction activities that serves a comprehensive reference tool for compliance monitoring is missing. Second is complying with site rules and regulation that adhere to specific site rules and regulation mandated by the region or the developer or contractor, ensuring alignment with legal requirements to avoid penalties and legal issues are not followed on site. Periodic evaluation of legal compliances, conducting internal and external evaluation to assess adherence of legal frameworks, identifying gaps and areas of improvement to enhance compliance measurements. Utilizing the legal register as a management tool, continuously referring to the legal register to monitor and assess compliance, ensuring ongoing compliance with laws and regulations throughout the project is necessary, and it is a challenge for the workers and supervisors present on site. Moving ahead with the case study, we had and prepared a case study as shown in the screen on the right hand side. The table below presents a statistical data regarding wages paid to construction workers on various sites around Adani Shantigram. Basically, we have taken data of 5 sites and on an average monthly wages with average working hour, we have calculated the percentage of workers paid below minimum wages and percentage of workers experiencing wages delay. As an inference, on an average 21.6% of the laborers are paid below minimum wages and 16.4% on an average experience delay in payments. Linear responsibility chart. We have prepared a linear responsibility chart for improvement of labor productivity on construction site. Below is the sample of the linear responsibility chart prepared, where the legends are R stands for responsibility, A stands for accountability, and I stands for informed. We have developed many multiple tasks and responsibilities, and we have segregated it into project manager, construction manager, site supervisor, skilled worker, semi-skilled worker, and unskilled worker, where development of productivity improvement plan, where project manager should be responsible, construction manager should be accountable, and other all can be informed. Here likewise we have prepared a detailed linear responsibility chart which inference into clarity of hierarchy of authorities, documentation regulated, monitoring control, clarity on work, and efficient resource allocation in order to improve labor productivity on construction site. Risk management for labor productivity on construction site. We have created a dashboard with step-by-step process which we have followed to analyze the risk, namely risk identification, risk assessment, and risk response. We also have given contingency plan to each and every risk. We have identified total 52 number of risks. The data was also validated at Adani Shantigram, Ahmedabad, during the survey carried out at 5 different sites. The projects were lump sum and fixed price contract too. The main importance of risk management is that the kind of project often increase the risk for the client if the contractor does not complete the project on time within the agreed cost or with the required quality. And that is why risk management and risk assessment is very much important. Here we have also given the severity assessment with multiplication of probability and impact. For an example, risk ID R1, namely delay in material deliveries, have the highest severity. The risk control strategy implemented on it is to establish reliable supply chain. The risk owner is procurement manager, and the contingency plan is to have maintained buffer stock, diversified suppliers in order to nullify this risk. Here on the left hand side top we can see the risk matrix with probability rated from 1 to 5 and impact rated from 1 to 5. The severity was calculated accordingly. On the right hand side top we have mentioned few of the risks which have been identified, namely delay in material delivery, skilled labor shortage, equipment breakdown, poor workmanship due to lack of skill, etc. The main inference of this risk management matrix is that there are total 52 risks identified during the study, and the highest severity found was of two risks, that is risk ID R1, delays in material deliveries, and second risk is risk ID 2, skilled labor shortage, was found to be maximum. And parallelly, we have given the contingency plan or mitigating strategies to the risk in order to nullify the effect on the overall project and construction labor productivity. Analysis of the surveys and interviews carried out during this directed research project for labor productivity on construction. The graph states the percentage of migrant laborers on site in Ahmedabad from other states. Inferencing this, based on the provided data and above figure, it can be inferred that Uttar Pradesh has the highest percentage of migrant laborers on the construction site, accounting for 35% of total migrant labor workforce from Uttar Pradesh. We have a primary survey result in which we have asked basic questions to laborers, that are, do they have record of their previous work? Are they satisfied with the wages? And are they exploited on construction site? As a result, based on the provided data in above figure, it can be inferred that there is no record of the data of previous work of laborers. There is less wage satisfaction, and the percentage of labor exploitation on construction site is higher, leading into low productivity. Foreman delay survey. For foreman delay survey, scope of work was identified in which AAC block activity of first 5 layers was optimized and observed. Then the observation of the activity was done and identification of man hours gained versus man hours lost was carried out and analysis of the workers was done. On the right hand side we can see a foreman delay analysis of man hours gained versus man hours lost, and as an inference we can see that the percentage of man hour worked is almost 1/4 compared to the man hour lost. As you can see in the graph, the comparison of all the workers containing 2 mason and 2 helper is showcased here. As seen in the graph, delays were categorized into 11 different categories, where major delay was observed in personal break by all the laborers, and helpers had a major delay due to inspection and discussion with site personnel during their job hours. Last planner system. The detailed data collection sheet is shared in the appendix of last planner system data collection. By employing last planner system, aim to achieve the standardization, quality control, efficiency and risk reduction in the project, leading to consistency and high quality outcome with high labor productivity while enhancing client satisfaction and monitoring the labor productivity. For variation analysis in last planner system, we have categorized variation into different codes. For example, approval, inspection, client-side issues, drawing in documents, formwork issues, material safety issues, manpower, plant and machinery, subcontractor side issue, weather, skill deficiency, non-working day, and other. For an instinct, for the cycle which for the concrete cycle which we have observed for last planner system, the major delay was due to the manpower deployment on the job site that contains 91%, and the other 10% was due to unexpected rain, so weather condition. Labor deployment in last planner system. So basically we have defined here the labor deployment for different activity, that is reinforcement installation and shuttering and de-shuttering. And we have shown the plan versus actual deployment of labors. As we can see in the figure, graphical visualization of daily labor deployment for reinforcement installation and graphical visualization of daily labor deployment for shuttering and de-shuttering, that was always manpower less deployed as compared to the plan by the labor contractor. Productivity analysis in last planner system. So here we have shown two major productivity analysis for two major activities, that is reinforcement installation and concreting activity. As we can see in the reinforcement installation, the actual quantity was 0.13 metric ton per man day and the plant quantity was 0.157 metric ton per plant day. The actual time taken for concreting was 18 days versus the planned was 12 man days. Moving ahead with the plus delta for last planner system, the initial low productivity then planned but significantly improved with the experience. Manpower issue from subcontractors side highlighted the importance of workforce planning. Effective management and resource implementation result into completion of the cycle time in 7 days, that was actually to be 9 days. Last planner system demonstrate effectiveness in enhancing productivity and providing value insight for decision making. Talking about some of the delta, the lack of communication between subcontractor posed challenges during the implementation of LPS. The top management's ability to effectively implement LPS on the project was limited, preliminary due to their lack of influence over all parties. The project faced a significant requirement for skilled laborers to handle finishing work, but the subcontractor's insufficiency in providing such skilled labor lead to change in priorities of the work. Several unavoidable obstacles were encountered during implementation process, including lack of commitment to change and innovation, unrealistic expectation, and subcontractors' failure to fulfill their promises. Work sampling was carried out on the project. Here we have shown a basic categorization of activities in crew block work. The value adding time contains block placing and watering. Non-value adding but necessary contains carrying blocks, mixing mortar, taking measurement, shifting materials, holding the blocks, handing over the material. And non-value adding time was standing idle, talking, sitting idle, busy on phone, waiting for material. On the left hand side bottom, we can see the site image where there are two masons and four helpers doing the job and making a single crew. Work sampling comparison. Here you can see a comparison of continuous sampling, random sampling and periodic sampling, combining it to an average of the percentage waste in value adding, non-value adding but necessary and no contact point of view. As you can see that the highest value adding time is for mason 2 and helper 4 compared to other laborers in the crew. As an inference to work sampling, the three alternative samples produce yield result that were comparable to one another. We can tell that continuous screw sampling method provides accurate result for the investigation. According to our study of the video, the block layer do not value add labor while the helper either do non-value added or non-value added but necessary work. In the video, the block work layer 2, that is mason 2, does more value adding work than block layer 1, that is mason 1, and he is more efficient. The mason helper 1, 2, 3 and 4 does non-value adding work, and the helper 5 has a no contact category of waste for about 90% of time and is the least efficient at all. We can also observe that the helpers having non-value adding but necessary time work caused a sustainable rise in the total of crew level percentage. Conventional productivity analysis case study 1. The data was collected for 14 days at site. The support panels for the solar panels with the size of 1000 square meter was observed. As per the observation on site, one panel was casted in 2 days. Here below on the left hand side we can see the productivity factors for seamless panels. As we can see that there is a total variation from the panel S60 to S68, and the highest labor productivity was found out in the S63 supporting panel. Moving on to the variation analysis, it was observed that highest variation analysis has the highest percentage of 31% of material mobilization on site, because it is a rectangular position, and if the laborers doesn't have the work front to operate the next activity, preceding activity, then there will be a delay and variation. And the most commonly observed variation over there was the uh, placement of materials after completion of the work. The second case study, which consists of calculating the cost per unit for different activities, namely shuttering and deshuttering, cutting and bending steel activities, and scaffolding activities. As it was a graph, there are higher spikes in the cost per unit calculation of per day, and on the 12th day you can see a clear hype of almost 90%. The X bar shows the average of the cost per unit per day, and the orange bar shows the permissible cost per unit given by the developer. Similarly, for the data analysis of cutting and bending on the right hand side, we can see that the clear penetration of the daily cost per unit from the average calculation of the cost per unit and permissible cost per unit. Samely, in data analysis of cost per unit for scaffolding also we can see the same. Now here in all the three graphs, for shuttering and deshuttering, the cost per unit given by the client or developer was 200 rupees per square meter. For shuttering, for cutting and bending steel, the permissible CPU was given as 35 rupees per meter, running meter, and for scaffolding the given permissible CPU is 30 rupees per cubic meter. The first recommendation as visual management. The actual purpose of visual management is to monitor the situation regarding whatever issue or subject is at hand. It is used to understand the described result and the current condition and to take action in correction to the situation achieved as desired result. The first and foremost and the easiest and most crucial part of implementing a visual management is using of color code uniform. There is already a need of uniform on construction site to identify different roles. What are we suggesting is simple. Each specific team will wear a different color to represent their role. For example, all workers wearing white helmet could represent a general workforce, while all spotters were orange, etc. Implementation of these colors would be easy as purchasing of new t-shirts and color armbands. So, with the discussion of site personnel at Shafurji, SPCL, and Reliance Industry, these are the color codes which we have come up with. For mason, it is earthly brown. For carpenter, it is deep green. For helper, it is light gray. For electricians, it is safety green. For plumbers, it is navy blue. For equipment operators, it is safety red, yellow. And for welders, it is dark gray. Now the main purpose of implementation of visual management is that when a layman enters a construction site, he is not able to recognize the person or the team. There are many episodes where unskilled labor pretend to be a skilled labor and hence hinder the labor productivity, concluding into rework. So visual management of color coding of the workers specific to their task will help us to reduce this kind of errors on the site. Labor productivity tracking device. Aim of the project is to design a portable device which will help construction manager calculate the productivity of laborers on site and the true cost of labor during the time they are employed. The device will conduct the output archived labor cost on and site core activities to calculate the overall labor productivity and make the data available in real time for site managers. The problem statement is the labor productivity remains a significant challenge in construction industry due to lack of real-time monitoring tools. Construction companies face difficulties in tracking labor activities and location accurately, leading to insufficiencies, project delays, and increase in cost. Traditionally, methods for manually tracking and time-consuming prompts to error and fail to provide comprehensive insight to labor productivity. Our solution is a wearable device equipped with advanced sensor including accelerometer, GPS module and a heart rate sensor designed to track labor activity and location in real time. The device continuously monitors labor movement, posture and heart rate to determine activities such as sitting without any work and sleeping. By integrating it with a cloud-based platform, the device provides a construction company with actionable insight and analytics to optimize labor productivity and enhance the project management. Wearable hardware components of the labor productivity tracking device are accelerometer sensor, GPS module, heart rate sensor, microcontroller unit, wireless communication module, battery, enclosure, and smart lock that the wearable will only be able to unlock by the scanner and with the help of an authorized person at the purchasing room or security. The band will be high tensile silicon band. It will be used for the device to be weared on the wrist. Talking about software components, sensor data processing algorithm, activity recognition algorithm, location tracking algorithm, heart rate monitoring algorithm, data fusion and integration algorithm, real-time tracking and transmission, cloud-based platform, user authentication and access control, alerting and notification system, and data storage and management are the major software required for the project. The key features of the device are real-time tracking monitoring, tracks labor activities such as standing, sitting, walking, sleeping using advanced sensors, location tracking, utilize GPS technology to monitor labor location both on-site and off-site, providing accurate positioning data. Data analytics, analysis of labor productivity metrics, efficiency level, and performance trend will be showcased. Safety alerts, generating alerts for unusual activity for a labor inclusion to its health. Cloud-based platform providing a user-friendly interface for accessing real-time data and generating reports and optimization of resource allocation. The major benefit of the device are to improve resource allocation, enabling construction companies to optimize labor deployment based on real-time productivity insight. Second is increase project efficiency, streamlining project management processes, reducing downtime and minimizing project delays. And cost saving, reducing labor related cost by maximizing productivity and minimizing idle time and eliminating inefficiencies. The future scope of work for the following topic is artificial intelligence integration, Internet of Things connectivity, and predictive as analysis. Artificial intelligence integration consists of self-learning capabilities, improving productivity, real-time monitoring, data interpretation, and future potentials. Internet of Things connectivity enhance the construction productivity with IoT, revolutionary technology for site management and near real-time optimization and benchmarking. Predictive analysis consists of predictive modeling, construction site management tools, time series regression model, and future trend in predictive model that helps to predict the nature of the construction project. Moving ahead with the conclusion. The survey insight at Adani Shantigram revealed regional distribution of migrant labor from states like Uttar Pradesh and Bihar, highlighted widespread wage dissatisfaction among laborers, identifying prevalent labor exploitation and emphasizing the need of ethical practices. Emphasize the importance of maintaining records for performance evaluation and resource allocation. CPO analysis in Ahmedabad, Gujarat explored critical issues in the construction industry and proposed strategies for the enhancement. Emphasized the role of modernization and adaptation to industry dynamics for productivity improvement and highlighted the external factors influencing productivity and identification of potential solutions. Legal compliance and labor productivity addressed legal implementation of labor safety and fair compensation in construction, highlighted gaps in compliance and the needs of regulatory reforms for industry sustainability, emphasized the importance of legal protection and for testing a productive work environment. Linear responsibility chart defined roles and responsibility of the project stakeholders to improve productivity, focusing on aligning individual effort with collective project goal for enhancing the efficiency. Risk management discussed the importance of identification, understanding, and mitigating the risk in construction in order to improve the productivity, highlighted the impacts of effective risk management on the project timeline and cost. Last Planner system demonstrated an advancement in scheduling, reliability, and productivity through collaborative planning. Showcased benefit of LPS in improving project predictability and resource optimization. Work sampling leveraged the data-driven technique to optimize resource allocation and reduce the idle time, provided actionable insight into crew-based activity to enhance project efficiency. Visual management for construction site efficiency utilized color-coded uniform and signage to enhance communication and safety and improve the productivity. Indirectly, promoted to a culture of accountability and efficiency through standardized visual clue. Labor productivity tracking device introduced wearable device for real-time tracking of labor productivity and activity and monitoring and data analysis. Emphasize the potential of technology in reshaping labor management on construction site.